After multiplication, it becomes easy to look at division, which is basically the reverse process of multiplication. So in this case, I'm going to look at the property of tangent theta, because if we look at our original diagram, so here's our length, there's our width, I had drawn in a diagonal, and I had indicated an angle theta. Well, a lot of times we want to know the angle, and we need to use trig to do that. Well, trig involves ratios of sides of a triangle. So if I take the ratio of the width to the length, that property is known as the tangent of the angle theta. And I don't really care right now what theta is. I just want to use tangent theta so that I can see the effect on what happens to a division property. So the first thing I'm going to do is look at what tangent theta is using my measured values for the width and the length. And I have no idea where I need to stop, so I'm going to use a lot of digits in my answer. That should be enough. If not, I can write more. And now I need to try and figure out how I'm going to get the biggest value of tangent theta. So I want the biggest value of that whole combination. If I make the width very big and I make the length very small using the ranges, then that should give me the biggest ratio available. And if you don't believe me, you can try by using the combination. You can use the highest width to the highest length, the highest width to the lowest length, etc. and see what happens. In doing this, tangent theta high ends up being 0.7751. I'm going to put it in another place just to be on the safe side, a couple more places. And I can see that the first two places stay the same, and this starts to deviate a little bit over here. So I'm going to find out how much that deviates. Okay. And notice that I wrote this to 3 decimal places because I just wanted to show you, kind of an idea what the numbers are before I finish up my final uncertainty. Similarly, if I do tangent theta low, this is going to be the lowest value for the width and the highest value, and that should give me the smallest ratio possible. Substituting in the values, 0.77258, or a difference of 0.017. So I ended up having a pretty uniform, there's some subtle differences later on, but I could get by saying my uncertainty now is going to be 0.0013, and that should encompass all the combinations I could have for the different values for the width and the different values for the length. So once I'm done with that value, then I'm going to just get rid of this, because now we want to be able to see how we take our values and make adjustments. We already know that this is going to be plus or minus 0.0013 to 2 sig figs, which means that this is the last decimal place that I have any faith in the precision. So matching that and rounding properly, 478 doesn't contribute to anything, and my value for tangent theta becomes 0.7738 plus or minus 0.0013. Having found tangent theta, I could go ahead, and I'm just going to slide this over so that I can see the values. I can go ahead and now use trig to see. So now I would use the calculator function that has the inverse tangent and calculate the highest angle I could measure, or calculate the lowest I could calculate, and then see what the ranges are. So if I look at what the theta would be by using 0.7738, And drum roll, please. It's 37.7327 degrees. Using my highest value for tangent theta, doing the inverse function on that, 37.7793 degrees. My lowest value would be 37.608. And I can see that my uncertainty, the deviation from the highest value, would be 0.0465. Well, now that's a problem, because now I'm starting to tell you 3 sig figs, and in the past, the most I've ever used is 2. And I used 2 because 0.00127 was on the small side, and writing that as 0.002 to 1 sig fig would be just too high. So I left it as 0.0013. Here, I'm going to go ahead and say, well, this is 465. That's actually closer to 5. And now it's a bigger number, and I'm going to keep that to 1 sig fig. Same is true for the low value. It ends up being 0.466, which can round to 5. So both of these, now we have a uniform high and low, and I am ready to write my final answer. Rounding properly and keeping it to the